In this video, I am going to discuss applications of system of linear equations. So, I am going to discuss 5 problems in this lecture. The first problem is this one. Let me read the problem. If X liters of regular gasoline, which cost $0.5 per liter, are to be mixed with Y liters of regular unleaded gasoline. So there are two types of gasoline, regular gasoline and regular unleaded gasoline. And regular one is X liters, regular unleaded one Y liters. And regular one is of cost $0.5 per liter. Regular unleaded one is of cost of $0.66 per liter. Now we want to make a mixture of 1000 liters, so that the cost for the mixer will be $0.6 per liter. Question is, how much of each gasoline should be used in the mixer? So since we want to make a mixture of 1000 liters, therefore first equation will be X plus Y equal to 1000. And second equation will be for the total cost. You see, 1 liter of regular gasoline $0.5. So you have X liters. Therefore the total cost of regular one will be 0.5x, 0.5x, plus for the regular unleaded one similarly 0.66y is equal, for the mixer cost per liter is this. So the mixer cost will be 0.6 into how many liters? 1000 liters. So the second equation will be 0.5x plus 0.66y is equal 600. So you need to now find or calculate the value of x and y from two equations by solving either method of elimination or in substitution. Here I use substitution technique. You see, I write y from the first equation, y equal 1000 minus x, and this y I replace in the second equation. 0.5x plus 0.66y equal to this, equal to 600. And after simplification, I found x equal 375 liters. So if you put x 375 in equation 3, you will get the corresponding value of y. That will be 625 liters. So in the mixer, there should be 375 liters of regular gasoline and 625 liters of regular unleaded gasoline. And the second problem, let me read the problem. We plan to invest X dollar in Acme company bonds and Y dollar in Star company bonds. And Acme gives us 6.5% interest. Star gives us 9% interest. Now you have $50,000 to invest, and you want to receive $4,000 as interest at the end of each year. So the question is, how much should be invested in each bond? So the first equation will be for your investment, that will be x plus y equal to 50,000. You want to invest total 50,000 in two company bonds. So x plus y will be 50,000, and second equation will be for interest. Since Acme gives us 6.5% interest, therefore second equation will be 6.5% of x plus 9% of y. This equal, you want to receive $4,000 as interest. So this should be equal to 4,000. So 6.5% means 0.065x plus 0.09y is equal 4000. So we have two equations. Now by the method of substitution I used here, but you can use elimination technique as well. By using substitution technique we calculate x and y. So it indicates that you need to invest $20,000 in ACME and $30,000 in STAR to receive $4,000 at the end of each year as interest. Now the third one is a mixture of pellets is to be made containing X regular pellets and Y large pellets, Z extra large pellets. There are three types of pellets: regular, large and extra large. Total number of regular pellet is given in your question, which is X, and large one Y, extra large Z. And the cost per pellet in cents is this 2. It means one regular pellet is of cost 2 cents, one large pellet is of cost 3 cents, and one extra large pellet is of cost 1 cent. And similarly weight is 1, 2, 4 respectively. Volume is 4, 2, 3 respectively. But the question is here, is it possible to make a mixture of 45 pellets? This is the question. At a total cost of this is the total cost, 85 cents. And this is the total weight, 120, and total volume, 130. So the first question will be for your cost. First equation will be for your cost, and second equation will be for weight, third equation will be for volume. So that's why you need to use first column for the first equation, second column for the second equation, and third column for the third equation. So first equation will be what? 2 is the cost of one pellet. So total number of regular pellet X, therefore total cost will be 2x plus total cost of large one 3y and total cost of extra large one Z, which should be equal to total cost 85 cents. 85. Note that if this data is given in dollar, you need to convert it into cents because the data given in the table is in cents. And for the weight, the total weight for the regular one will be 1 into x. So x plus 2 into y plus 4z is equal total weight 120. And the third one for volume will be 4x plus 2y plus 3z is equal total volume 130. So now you create a linear system from the given problem that contains three equations, and you need to check whether it is possible to make a mixture of 45 pellets or not. How can we do that? The solution we will obtain from this system need to satisfy this equation, x plus y plus z equal to 45. If the solution of this system, the addition of the solution of this system gives us 45, it means mixture is possible. If not, then mixture is not possible. So let us calculate the solution of this system. The procedure I have explained in my previous lecture. You need to first eliminate x from equation 1 and 2. To do that, the x coefficients need to be same. So we need to multiply equation 2 by 2 and then subtract equation 1. That gives us y plus 7z equal 155. And again, you can use either equation 2 and equation 3 to eliminate x from the third equation, or you can use equation 1 and equation 3. So here I used equation 1 and 3, and to make the coefficients equal in 1 and 3, I multiply equation 1 by 2 and then subtract equation 4. That gives us equation 5. And from 4 and 5 you can again eliminate either y or z, and you need to multiply equation 4 by 4 to eliminate y, or if you want to eliminate z, you need to multiply equation 5 by 7, then add equation 5 by 7, then if you add with the 4 you will get y. So y equal to 15, and if you put y in the equation 4 or 5, you will get z, that is 20, and y and z, if you put in the first equation or second equation or third equation, you will get x, that will be 20. Now you see that the summation of the solution is 45. 15 plus 20 plus 10, which is 45, which indicates that the mixture of 45 pellets is possible, and the corresponding number of pellets will be 10 regular pellets, 15 large pellets, and 20 extra large pellets. However, if I put, for let's say everything in the question is same, but here I put 46, so which indicates that the addition is not for 46. Thus what will be our decision? The mixture of 46 pellets is not possible. Now the fourth one, in this problem there are three products: product A, product B, and product C, and three departments need to work in order to produce one product. For example, if you want to produce product A, 1 unit of product A, then department 1 needs 1 hour, department 2 needs 1 hour, department 3 needs 2 hours. Similarly, for example, product C, department 1 needs, if we want to produce 1 unit of product C, department 1 needs to work 9 hours, department 2 needs to work 7 hours, and department 3 needs to work 13 hours. And the main restriction is here. Department 1 has 75 hours available, department 2 has 65 hours available, department 3 has 125 hours available. And you need to find the total number of units of three products. Let's say total number of units of product A is X, total number of units of product B is Y, and total number of product C is Z. So what will be the corresponding linear system? We need to here create first equation using first row, and second equation using data given in the second row for department 2, and third row is given for department 3. So the first equation will be for 1 unit, department 1 needs 1 hour. Therefore, for X units, department 1 needs how many hours? X hours. For Y units, department 1 needs Y hours, and for Z units, department 1 needs 9Z hours. Therefore, the first equation will be X plus Y plus 9Z equal, and department 1 has 75 hours available. So this equal 75. and second equation will be what? Similarly, x plus 3y plus 7z is equal 65, and third equation will be what? 2x plus 7y plus 13z is equal 125. Now by solving, you need to calculate the solution of this system. So the procedure is exactly same what I discussed before in this lecture and previous lecture. You first need to eliminate x from equation 1 and 2, that gives us equation 4, and from 1 and 3 again if you eliminate x you will get equation 5, and you see that 4 and 5 are exactly same equation, so you can forget about equation 5. Now in the converted system I have explained in my previous lecture clearly, so you can have a look there. In the converted system you have two equations, equation 1 and equation 4. Or eliminated system you have two equations. Now you have two equations in three variables, so one variable need to consider as an arbitrary variable. You can consider either y as an arbitrary variable or z as an arbitrary variable. Let's say z arbitrary. So you need to write y in terms of f, in terms of z. From the second equation, y equals z minus 5, and from the first equation x will be 75 minus y minus 9, z should be here, 75 minus y minus 9z, and 75 minus y is equal to this from the second equation, and which means this 80 minus 10z, 80 minus 10z. But here x, y, z indicates number of units of three products. Therefore, z arbitrary is not true for this real problem. Z arbitrary means you are allowed to consider any real value which can be positive or negative. But z indicates number of units, y indicates number of units, x indicates number of units. So x, y, z should not be negative. They can be positive or 0. Therefore, this condition is not true. Z arbitrary is not true for this real problem. What you need to find a range for z so that x, y, z will be positive or 0. And this is important to understand where you will get that range. That range you will get from these equations. If you put z equal to 5 in the second equation, y will be 0. So the lower limit of z will be 5, because if you put 4 for z, y will be negative. So y 4 is not allowed for z. And 6 is okay, 7 is okay. We understand that the lower limit of z is 5. Z should be bigger than 5 or equal 5. And from here, first you need to look which z makes x 0. x এর কোন মান, z এর কোন মান x কে 0 করে? If z equal to 8, then 80 minus 80. And if you put z equal to 9 in this equation, x will be negative. So the maximum range for z will be 8. So from these equations we can say that in order to make x, y, z positive or 0, z should be within 5 to 8. It means z should be either 5 or 6 or 7 or 8. So the general solution for this real problem is this, and this is the answer of part A. Now part B, it says in order to find maximum profit, what should be the values of x, y, and z? What should be the outputs? So The profit per unit of A is $20. From 1 unit of A, profit $20. So from X units of A, total profit will be 20X. And for Y units of B, total profit will be 30Y. And for Z units of C, total profit will be 40Z. So our profit function in this case will be what? This is the profit function, and note that P depends on X, Y and Z. So instead of writing P, you should write, it will be better if you put P as a function of X, Y, Z, because P depends on X, Y and Z. So this is your profit function, but we already have X and Y in Z. So I can put X equal to 80 minus 10Z, Y equal to Z minus 5 and Z is in Z. After simplification, profit function. In the second equation, profit now depends on only Z, since I replace X and Y by Z. So PZ is now 1450 minus 130Z. This is your profit function. Now, which Z makes profit maximum? Let me denote maximum profit by P max. Maximum profit, which Z? Z is from 5 to 8. You see, because of this negative sign, P max should be for lower Z, it means for 5. When Z equal to 5, P will be what? 1450 minus 130 into 5. This equal 1450 minus 650, which is equal $800. The profit will be maximum profit will be $800. Why I used the lower value of Z? Because of this negative sign. If you put 6, then it will be the figure will be more smaller. So P max is for Z equal to 5 units, and Y corresponding Y will be Z minus 5, 5 minus 5, which is 0, and corresponding X will be 80 minus 10 into 5, which is 30. X equal to 30 units. So the maximum profit $80, and the composition of the maximum profit combination of outputs are 30 units of A, since X equal to 30, and 0 units of B, 5 units of C. 5 units of C or no B. This is the result. And the last one in this lecture is this problem. Let us read the problem first. There are 3 types of gasoline: regular gasoline and premium gasoline, super gasoline. And company wants to make a mixture of 2000 liters. So let's say the question is, what amount should be what amount of each gasoline should be in the mixture. Let's say the regular one will be X liters, premium one Y liters, and super one Z liters. Note that the profit, the cost should be minimum. So the first equation will be X plus Y plus Z equal 2000, since you want to make a mixture of 2000 liters. And second one will be for octane rating. Octane rating of regular gasoline 80 rating. So the total octane will be 80x. Second equation will be 80x plus octane rating for the premium one 90. So it will be 90y plus octane rating for the super one 100. So 100 Z is equal octane rating for the mixer 85 into 2000 or 2000 into 85, since the mixer is of 2000 liters. Now dividing both sides of this equation by 10, you will get second equation, this one, and this is your first equation. And third equation you can create for the vapor pressure index. Vapor pressure index for the regular one is 30, for the premium one is 20, and for the super one is 10. So the third equation will be 30x plus 20y plus 10z is equal, for the mixer pressure index 25, so it will be 25 into 2000, 25 into 2000. So this is the third equation, and we can also divide both sides by 10 to simplify it. So this is your third equation, and like before, exactly what we did before, you can eliminate either x or y or z from equation 1 and 2, and from 1 and 3 you can again eliminate x. Note that at first, if you eliminate x from 1 and 2, you must need to eliminate x from 1 and 3. But at first, if you eliminate y from 1 and 2, you must need to eliminate y second time. And first time, if you eliminate z from 1 and 2, second time you must need to eliminate z. So here I eliminate z from 1 and 2 at first, and second I eliminate z from 1 and 3. So you see 4 and 5 exactly same equation. Therefore, in your eliminated system or converter system, you have now equation 1, that is x plus y plus z equal to 2000, and this equation. So this is your converter system, x plus y plus z equal 2000, and 2x plus y is equal 3000. So you are now allowed to consider either y or z as an arbitrary variable, since in the second equation you have x and y. But তোমার মাথায় কোশ্চেন আসতে পারে যে আমি কেন z কে আরবিট্রারি ধরতে পারবো না? If you want to consider z as an arbitrary variable, from this system you cannot do that. But if you want to consider z as an arbitrary variable, you should not eliminate z at first from 1 and 3. You need to keep z to make equation 4 in y and z or x and z. But here this is our eliminated system, so I can consider either x or y as an arbitrary variable, since number of variable 3, number of equation 2, so one variable should be arbitrary variable, and here I consider x arbitrary. So from the second equation, y is equal 3000 minus 2x, and from the first equation z will be what? X minus 1000. Now z arbitrary is not true for a real problem, so you need to find a range for x to make x, y, z positive or 0. Since this is a real problem and x, y, z indicates number of liters, so x, y, z should be bigger than or equal to 0. Now how can we find a range for x? That you can find from this equation and this equation. First you need to look which x makes z 0. It is 1000. If you put 1000 for x, z will be 0, and if you put 1500 for x, y will be 0. So we can easily write that the range for Z will be 1000 to 1500. So this is the solution. But in order to make cost minimum, we need to find the cost equation. Cost equation will be what? From the question you see the regular one is of course $0.3 per liter. So total cost will be 0.3x, 0.33y, 0.04z. That is your cost function. C equal 0.3x, 0.33y, 0.4z. Now you know y and z. You know y and z. Y is equal to this and z equal to this. So if you put y and z in equation star and simplify it, your cost equation will be in terms of x. Here c depends on x, but here c depends on in a star c depends on x, y and z. Here c depends on x only. So now the question is, which x makes cost minimum? It should be 1000. If you put 1000 for x, c will be minimum. It means c mean. Let us denote c mean minimum cost by c mean. For 1000, that will be 0.04 into 1000 plus 590, which is equal 440 plus 590, which is equal $630. So $630 is the minimum cost when x equal to 1000, and corresponding y will be what? 3000 minus 2 into 1000. It means y will be 1000, and z will be what? Z will be 1000 minus 1000, 0. So in order to make a mixer of 2000 liters and cost need to be minimum, the total mixer should contains 1000 of regular unleaded gasoline and 1000 liters of premium unleaded gasoline and 0 liters of super unleaded gasoline, and the minimum cost is this. So that's the end of this lecture. Hope you enjoy the lecture, and if you have any question you can write in the comment box. Thank you very much for your listening.